Hello, it's time to add some vectors. Okay, so one of the great things about vectors, right, is you can add and you can subtract them. Right now, multiplication gets a little funky, and you can never divide. Yeah, so if you ever see this, it is surely wrong. Wrong. Can't do that. All right, now multiplication's weird. We're going to talk about it later on. You can always multiply a vector by a scalar. So you kind of write like F equals ma, right? The a is the acceleration. The m is the mass, which is a scalar. So the scalar times a vector gives me a vector, right? So you're always allowed to do that. All right. For vector addition, you can do it, right? So if I have one vector, a, and I know that a is equal to b plus c, right? I can always figure out what that sum is. So let's say I have the following vector. Let's say I have b is equal to 3i hat plus 2j hat, and c is equal to 1i hat minus 4j hat. All right, what's one way to do this? Well, one way to do this would be graphically. Okay, so x, y, I have my handy dandy ruler. I'm going to mark off every inch here. Boop, boop. If you do a graphic method, it's really important that you have a ruler, because the actual getting the angles and things right actually really matters on the size. So having a ruler is really a handy dandy tool for determining distances when you're working with when you're working graphically. Okay, so we want to plot what b is, right? So it's going to go 3 steps in the x direction. So 1, 2, 3 steps in the x, and then 2 steps in the y direction. 1, 2. So my b vector is going to point like there. Okay? That's b. Now, if I look at c, if I want to figure out what that is, what I do is I go to the end of b, okay? And then I treat that as my new origin. So this is the starting point of c. And I look at c, I'm going to go 1 step over and minus 4 steps down. So let's see, I'm going to make some lines here. So I'm going to go one step, 2 steps, 3 steps, 4 steps, and make a line there. So C goes from this point here, it goes over 1 to the right and then down 4. And now if I want to determine what A is, which is just the sum of B plus C, right? I go where I start A at the beginning of B, here, and I go to the end of C. Right? So yeah, so this is A actually, right? The end of C. So I form kind of like a triangle-y thing there, right? So I start at B and I end at C. We'll call this tail. Sometimes it's tail to head or something like that. I don't really get much into calling these various things, but one might see that if you look into some textbooks. So if I want to figure out then what A is, having done this graphically, I can go 1, 2, 3, 4. It's over 4, 4i hat. And it's going to be down 1, 2, minus 2 j hat. Okay, so that's my A vector, done graphically. Now how about doing it mathematically? Well, I know that B plus C equals A. So B is going to be 3I plus 2J, right? And C is going to be 1I hat minus 4J hat. So what are they going to give me? Well, if I'm adding them, I know only the things in the x direction can affect the things in the x direction, and only things in the y direction can affect things in the y direction. So 3 plus 1 is 4I hat. Okay? 2 minus 4 is minus 2J hat. Boom. Algebra gives me the same as it does graphically.